Hello, everyone. This is Jessica from Milesight marketing team, and welcome to the Milesight Comprehensive Product Line Application course. Thank you so much for taking the time to join us. In the last course, we focused on indoor smart building management. Today, we'll move from indoor to outdoor environments to explore smart city-related applications. We have a lot of exciting content to cover, all centered around how Milesight supports smarter cities through real-world cases. Our session is divided into 4 main parts. First, we'll start with a quick smart city overview, including our product on matrix and the core solution areas we focus on. Then we'll dive into 2 of the most important aspects of a city, namely smart water and cold chain management. We'll look at our 3 W water Y strategy and 4 our cold chain strategy and see how they are deployed. Finally, we'll wrap up with environmental monitoring solutions, including fire detection, smart waste bins, and more. Let's get started. Currently, we have more than over 100 products. Our offerings include sensing nodes, connection devices, and various additional tools and platforms. Our sensing nodes are designed to gather accurate data from the environment. Most of the nodes support LoRaWAN protocol, and a few of them also supports some other communication protocols, such as 4G Cat1, Wi-Fi Halo NB-IoT, and LTE-M. Milesight controllers are designed to offer seamless integration with the legacy or traditional sensors. And the weather stations are commonly deployed in smart city and agriculture applications or solar power plants, where accurate weather data is essential. To facilitate seamless connectivity, we provide a range of connection devices that enable efficient communication between devices and networks. These devices play a crucial role in establishing secure and robust connections, such as the LoRaWAN gateways, cellular routers, and switches. Recognizing the potential of 5G technology, Milesight has developed 5G suites that leverage the power of this advanced network infrastructure. These suites enable high-speed data transfer, low latency, and enhanced reliability, unlocking new possibilities for IoT deployments. In addition to our broad product range, we offer extra software platforms tailored to cater to the diverse needs of our customers. Let's take a step back and look at the bigger picture of how Milesight supports smart city development. Cities today face some serious challenges, whether it's ensuring the safety of food and medicine, preventing floods, reducing pollution, or improving infrastructure efficiency. And that's exactly where our solutions come in. We focus on 3 key areas. On the left, there's cold chain management. This covers every stage from production and storage to transport and final delivery, whether for food safety or medicine effectiveness. On the right, it's all about smart water management. We're talking about monitoring water levels, pipes, meters, and even managing irrigation and fountains, which are daily tasks for public facility managers. And in the center, we've got environmental monitoring, with a strong focus on public safety, like detecting fire risks and managing waste through smart bins. Together, these solutions help make our city smarter, safer, and more sustainable. Next, I'll walk you through the Milesight Smart Water solution for urban areas from 4 main perspectives. But before we dive into some real-world examples, I'd like to give you a quick overview of the 5R actions, powered by Milesight's 3W Water Y strategy. Milesight's 3W Water Y solution is designed to reduce water losses and optimize urban water management through 5 key actions known as the 5Rs. The first R is retrofit. It means upgrade and read water meters to ensure accurate measurement and monitoring. The second R is refill. This involves deploying public water refill stations to encourage reuse and reduce plastic bottles. The third R is reuse. This refers to powering greywater irrigation systems to make use of wastewater for non-potable applications. The fourth R is repair. This signifies detecting and clearing leaks and blockages to prevent water losses. The last R is reduce. That means cutting down on unnecessary water discharge by adjusting based on the actual water level. These actions are supported by three core solutions. Number one, water meter retrofit. Upgrade pulse counting meters and reading meters using Modbus and DLMS protocols. Connect solenoid valves to achieve smart irrigation and fountain control, ensuring efficient water use. Number two, pipe and sewer monitoring. Monitor pipe and sewer blockages, environmental conditions, and pipe pressure. Analyze overall pipe health to maintain a reliable water distribution system. Number three, water level monitoring. Track rainfall and keep an eye on surface water and storage tank levels to monitor drains and prevent flooding. This slide lays out Milesight's 3W WaterWise solution product matrix, showing which devices serve each water management domain. Let's start with water level tracking. We've got two smart solutions working together here. Underwater probes stay submerged to constantly measure levels, while our non-contact ultrasonic and radar sensors act as safety guardians from above. They work in harmony to prevent overflow risks. Now for the lifelines underground, our water pipes. We rely on three trusty detectives: the EM500 carbon dioxide sensor, EM410 radar sensor, and EM500 pipe pressure sensor. These workhorses continuously monitor pipe conditions, helping spot potential leaks or blockage before they become major issues. Upgrading our metering game. Absolutely. While we're already using EM300 pulse counting sensors and UC series controllers to handle pulse output and Modbus meter data. Here's the exciting update. Our UR3X routers will be getting DLMS protocol support in the third quarter this year. This means seamless communication with DLMS compliant meters, finally bringing all your smart metering under one unified system. For urban water optimization, check out these two game changers, the UC51X series controllers. These smart devices automate irrigation systems through solenoid valves, adjusting water flow based on actual needs. The WTS506 weather station, your personal rainfall reporter. Its live weather data helps make informed decisions, like delaying irrigation after heavy showers or preparing drainage systems for storms. Together, these sensors and controllers connected over LoRaWAN or cellular provide end-to-end visibility and control across the urban water cycle. Let's walk through how the whole system comes together, from sensors to insights. First, once you deploy the smart sensors, you immediately start gathering a wide range of data across your water infrastructure. All this data is transmitted wirelessly to a Milesight LoRaWAN gateway, which can come with a built-in network server. This means you don't need to set up any complex backend infrastructure just to get started. If you're using the built-in lens on the gateway, data can be forwarded directly via MQTT or HTTP or HTTPs. Alternatively, if you want to keep things simple, you can use the Milesight development platform. It's plug-and-play platform that automatically handles connectivity, management, and built-in LS services. It means you don't need to perform complex technical operations on the hardware layers. You can just use the development platform to auto-provisioning devices and unified output data from different standards. Just simply power on your devices and add them to the platform. From there, you can use APIs and webhooks to easily integrate this data into your own application or third-party platform, or even to Beaver IoT platform for unified data calls and pushes. Once the data lands Beaver IoT or your own platform can be processed, visualized, and turned into actionable insights, so business users, facility managers, or city planners can make smarter, faster decisions. By retrofitting existing water meters with Milesight controllers, pulse counters, and DLMS-supported routers, cities gained real-time monitoring capabilities for water consumption and distribution. These technologies enable precise tracking of water usage, early detection of leaks, and enhanced control over water resources, ensuring that water systems remain efficient and sustainable. Here's a simple breakdown of how to upgrade different types of meters to IoT networks. First up, pulse output water meters. These non-electric powered meters come with a built-in rate switch and magnet, making them super easy to upgrade to LoRaWAN. Just slap on an EM300DI or UC51X controller, no extra parts needed. It's a low-cost and straightforward way to go wireless. And for industrial meters with RS485. If your fancy meters already speak Modbus over S485, you're in luck. Plug and play with UC100, 300, and UC500 controllers. They grab data via RS485 and shoot it over LoRaWAN. Zero extra parts, instant smart meter. And sometimes you may have water meters that support DLMS protocol over RS485. DLMS is an internationally recognized smart metering communication protocol. It's widely used across electricity, water, gas, and heat metering. Let's see what we can expect in the third quarter for smart metering. The first example comes from a warehouse in Sydney, Australia. The customer implemented an energy management system to monitor their warehouse's energy and water consumption. However, they encountered a logistical hurdle with a water meter in a remote area where traditional wiring was impractical. So our partner Contact Automation decided to invest in a water retrofitting solution with real-time data via LoRaWAN to bring down water loss. The project with a pilot in the warehouse where a fixed network with UG56 LoRaWAN gateway and EM300DI pulse counter was installed. Today, the warehouse facility managers is notified by alarms from the pulse counter sensor whenever leaks or bursts occur in their distribution network. Within the first 30 days of operations, 10 alarms were identified and fixed within just hours of occurrence. The real-time monitoring of water consumption has resulted in an immediate drop in the warehouse's water loss. More than 10,000 liters have been saved so far. Let me tell you about a fantastic success story in Australia involving test water and meat pet. Each year, Australia faces a massive issue with plastic water bottle pollution, with hundreds of millions of bottles discarded and only 30% being recycled. In Tasmania alone, more than $15 million is spent annually on bottled water. To tackle this problem and promote sustainability, Taswater, the sole water utility company in Tasmania, partnered with Meatpat, a renowned water station manufacturer, to deploy innovative water refill stations equipped with EM300DI pulse counters. These refill stations were strategically installed in bustling spots across Tasmania, allowing people to easily access clean tap water and refill their bottles. The pulse counters integrated into each station monitor real-time water consumption, seamlessly forwarding data through the public LoRaWAN network. This setup not only helps track water usage, but also addresses the challenge of monitoring consumption in remote areas. In 2024, 30 refill stations were installed, significantly reducing water waste. These efforts helped cut down the amount of single-use plastic bottles sent to landfills by approximately 130 kilograms per year. Additionally, apart from test water, approximately 400 refill stations have been adopted by other utilities and installed in metropolitan cities like Sydney. Parkshire Council, located in central West New South Wales, Australia, is famous for its giant radio telescope and Elvis Festival. But now it's also known for its innovative recycled water scheme, launched in 2020. The goal? To keep parks and green spaces lush and green even during droughts without using precious drinking water. Traditional irrigation methods rely on fresh water, which leads to water scarcity, soil degradation, and ecosystem disruption. Using treated wastewater, recycled water for irrigation, is a sustainable alternative, but it must meet strict standards and be managed effectively. Therefore, the City Council turned to LoRaWAN technology to make their recycled water irrigation system smarter and more efficient. Here's how they did it. Milesight UC501 multi-interface controller connected to an octave water meter via RS485. Milesight EM300UDL ultrasonic distance level sensor were installed in a dam to monitor water levels. These devices send data over the Things network to the Indicium databus. The data is integrated into a digital twin of the water pipeline system. The digital twin is periodically evaluated to decide if valves need to be turned on or off. Data is stored in Azure Table Storage and Azure Data Lake for reporting and analysis. Visualization is handled by Indicium Cloud. By using IoT technology, the City Council has created a smart, efficient, and sustainable way to keep their green spaces greener, without wasting precious drinking water. Why replace when you can upgrade? There are several options for legacy systems upgrade. The UC100 works as the bridge between your legacy RS485 devices and the modern LoRaWAN world. Meet the UC300, a multiple input and output powerhouse built for indoor applications only. Inside its IP30 case, you get digital inputs, relay outputs, analog channels, RS232 and RS485 ports, even PTE100 RTD support, so you can hook up pumps, valves, temperature sensors, or alarms all in one box. Imagine a water meter that not only talks back over LoRaWAN, but also filters out any stray spikes for rock-solid pulse counts. Meet the EEM300DI. This rugged IP67 rated counter filters interference and lets you refresh, clear, or accumulate counts on demand. Even better, it has built-in temperature and humidity sensors, so you can see how environmental changes affect usage. When you need a rugged outdoor IoT hub that never quits, that's the Milesight UC500 series. Housed in an IP68 enclosure, built to shrug off rain, dust, and vibration. These controllers boast GPIO, analog inputs, serial ports, and an SDI12 interface, so you can plug in weather stations, hydrological probes, soil sensors, you name it, for true environmental data acquisition. Here's a comparison table for your reference. Feel free to look it over whenever you have time. Now it's turn for smart metering via DLMS protocol. Device Language Message Specification is a commonly used protocol that facilitates communication between utility control centers, data concentrators, and smart meters. At Milesight, we hook up to meters over RS485 serial port in a classic client and server setup. Our router acts as the client and polls the meter as the server for data. We often see customers mixing up IEC6205621 with DLMS, but IEC6205621 is really just the old school optical and serial handshake protocol and isn't the same as DLMS, so it's not supported on our routers. DLMS, on the other hand, runs over COSEM, the companion specification for energy metering, which gives you the application and transport layers, plus built-in security for authentication and encryption. According to our plan, the COSEM implementation will allow you read every register on a DLMS meter, but writing back to those meters won't be supported. If everything goes smoothly, these 4 models with serial ports, UR3235, UR41, and its light version, will support the DLMS protocol by the 3rd quarter of this year. Effective management of sewer systems is essential for cities to adopt preventive sanitation strategies, mitigating contamination risks, and ensuring cleaner, safer urban ecosystems. Milesight's radar distance level sensor measures water levels in sewer systems, detecting potential blockages or overflows. Additionally, the outdoor carbon dioxide sensor monitors environmental conditions, allowing for the prediction of potential pest issues. Let me walk you through a real-world sewer blockage case, right here in Xiamen, China. The EN410 RDL radar sensor continuously measures the wastewater level beneath the manhole. We feed that data into a machine learning model from a local partner that learns normal flow patterns, dry weather, wet weather, even the morning and evening wastewater rush hours. As soon as levels start creeping up beyond the learned norm, the system fires off an alert, signaling that a blockage is forming downstream. Thanks to this early warning, utility crews armed with high pressure water jets can clear the developing fatberg before it turns into a full blown sewer backup. So far, we've prevented one garden from flooding and spared three commercial buildings the misery of internal sewer flooding. In Cordoba's historic Paraíso Arenal district of Spain, a collaboration between the University of Cordoba, the City Council, and the municipal sewage company deployed Milesight LoRaWAN sensors to predict American cockroach outbreaks underground. Cockroaches thrive in the rising summer heat and 90 to 95% humidity underground, creating perfect breeding conditions. When these conditions peak, cockroaches seek escape routes. However, under the EU Green Deal, the European Commission aims to reduce chemical and hazardous pesticide use by 50% until 2030, mandating safer and smarter alternatives. In response, biology researchers at the University of Cordoba, the City Council, and the Public Sewage Utility joined forces to pilot a smart, data-driven pest control approach. During the first phase, the Milesight EM300TH and EM500 carbon dioxide sensors are deployed in different zones to collect various data. Over a 4-month pilot, temperature, humidity, carbon dioxide, and barometric pressure data were streamed from IP67 rated lithium battery devices into the cloud. Specialists then built a process-based model to correlate environmental swings with pest activity and generated real-time heat maps to guide precisely timed interventions, cutting pesticide use at the source and minimizing public discomfort. Fire protection systems are life-saving infrastructure in every city, but many of fire protection systems across China are not being inspected as they should be. Therefore, instead of sending inspectors to the field, where they can only get to a few job sites a day, a more efficient process would deploy smart devices that allow these inspectors to monitor remotely. So LoRa makes life easier and cooler, but also promises to enhance the efficiency of the fire protection systems that are designed to provide life safety. For example, in a logistics park located in Shanghai, we've upgraded the fire protection systems with smart technology using Milesight pipe pressure sensors and submersible water level sensors. Both are from the EM500 series. The pipe pressure sensor can measure a range of 0 to 16 bar on pipes, and pipes are G 1/2 inch in size. When we check on pipe health, we can focus on 3 things: whether there's any blockage, what the pressure readings look like, and how the surrounding environment is behaving. So the EM410 RDL sensor tackling harsh underground conditions, where needed a sensor that could live inside concrete pits under metal manhole covers, no aluminum or steel allowed, only a corrosion-proof BVDF housing in a sleek finish, plus an IP68 rating to survive high humidity. Next, meet the EM500PP, your go-to low and pipe pressure detective. It snaps onto any standard G 1/2 inch fitting and keeps a constant eye on pressures from 0 to 1600 kilopascals. Then, think of the EM500 CO2 as a detector for pipe surrounding environment. In one rugged IP65 rated housing, it measures carbon dioxide concentration from 400 to 5,000 parts per million, with a barometric pressure from 300 to 1100 hectopascals, as well as temperature and humidity. Flooding is one of the most dangerous risks that urban areas face, especially in regions prone to heavy rainfall. To protect residents and infrastructure, Milesight's radar level sensors, ultrasonic level sensors, and submersible water level sensors. They can offer real-time water level monitoring in rivers, reservoirs, and storage tanks. Bringing real-time flood monitoring system to fingertips with Milesight IoT solutions in Austria. The location is too remote and difficult to reach to maintain effective management for people, especially in wintertime. So our customer installed several ultrasonic distance level sensors and submersible water level sensors next to the dam to measure the upstream and downstream water level every 10 minutes. Ultrasonic distance water level sensors can be easily installed above the river surface beneath a small bridge for non-contact monitoring. Additionally, The submersible water level sensor can be attached to an iron pile that fixed to the river bottom for precise monitoring, regardless of whether the river experiences rapid flow during flood season or calm flow during normal periods. After connected to an existing solar panel and an external cellular antenna, Milesight LoRaWAN gateways now are powered to provide stable signal coverage. Through the TTN network server, the collected data finally reaches to the customer's platform for further analyzing. Here's how a tiny Colombian village reduced water waste without digging up a single pipe. Imagine tracking water tanks in mountains with zero cell signal or leaky pipes drained 30% of their supply. Manual checks, a day-long hike for a 5-minute reading. Budget, tight as a drum. Therefore, the LoRaWAN-based solution is the best choice. The EM500 submersible water level sensors tossed into water tanks to measure levels, regardless of rain or shine, last 10 years on a battery. UC501 controllers hooked to flow meters via the RS485 serial port, sending data via LoRaWAN even in the boonies. UG56 gateway is solar-powered, rugged as a goat, relays data to the cloud from the middle of nowhere. The Milesight cloud dashboard shows tank levels, leaks, and flows in real time. See, with all hardware and software provided by Milesight, you can quickly build an end-to-end smart water management platform with minimal investment. In New Zealand, the Cook Islands embarked on the Smart Islands project to enhance water efficiency. To enable efficient monitoring and analysis of the water distribution system, the project utilizes LoRaWAN technology. At each intake point, various LoRaWAN sensors from Milesight are employed to monitor different parameters, including tank levels, pressure, and water volume produced. Totally, over 600 sensors are deployed to tackle challenges in water management. After treatment, the water from the 10 main intake points is transported to the main distribution ring. Each intake point is connected to the main ring through pipelines equipped with connection points. These connection points are installed with water meters and Milesight EM500 pipe pressure sensors to facilitate pressure monitoring of pipe pressure and leakages. The data collected by these sensors and the LoRaWAN Modbus transceivers UC501, which are connected to the water meters, are transmitted using LoRaWAN technology. From the central ring, smaller distribution pipelines extend to individual consumers, delivering water to their respective locations. As part of future plans for the intakes and distribution, more sensors will be installed to further enhance the efficiency of the system. In short, deployed EM500 pipe pressure sensors and submersible water level sensors across pipelines and tanks. Caught leaks fast, balanced water pressure, and tracked rainwater reuse, cutting waste and keeping taps flowing. In a Middle Eastern country facing extreme aridity, preserving precious drinking water is a lifeline. To combat rapid evaporation under scorching desert sun, communities store water in underground reservoirs. However, monitoring these buried tanks posed a challenge due to limited connectivity and harsh environmental conditions. Milesight's EM410 RDL radar distance measurement device proved to be the ideal solution for this scenario. The device was equipped with a 10-meter external cellular antenna extension cable to ensure stable signal transmission from underground to the cloud. The radar technology of the sensor allows for precise and non-contact measurement of water levels, even in challenging environments. The sensor's rugged IP68 design withstood dust and extreme heat up to 70 degrees and extreme cold lower to minus 35 degrees Celsius. Let me take you to Nevis, a lush Caribbean island where fresh water is precious and infrastructure faces some serious challenges. The Nevis Water Department needed a rock-solid way to monitor tanks, pumps, and pipelines without getting fried by lightning or wrangling miles of cable. That's where our partner Mnet Pro from Colombia stepped in. We rolled out a full LoRaWAN network across every tank, booster station, and wells on the island to integrate with customer SCADA system. Hardware mix with 27 UC300 controllers, 9 ultrasonic water level sensors, and 13 pressure sensors. as well as 6 units of UG67 outdoor gateways, each backed up with UPS-01 uninterruptible power supply. Before came to Milesight, the end-user Nevis Water Department installed some PLCs and legacy transmitters. But because of the environment, frequent lightning strikes were breaking PLCs and analog transmitters at the tank sites. And those remote, high-altitude tanks, they had no reliable power, and running wires was cost prohibitive. In addition, pumping stations with variable frequency-driven motors needed real-time electrical parameter data and pump control. Yeah, all of these, our customer wanted to resolve them by LoRaWAN wireless communication. Therefore, we clipped EM500 ultrasonic level sensors atop each of the 9 tanks for water level monitoring. No cables, no lightning kill switch, just battery-powered readings every few minutes. And the 27 pieces of UC300 controllers physically handled meter reads and pipeline pressure inputs through the 4 to 20 milliampere analog inputs. 6 UG67 LoRaWAN gateways, each co-located with a UPS-01 pack, became reliable LoRaWAN hubs even when the grid cut out. Our partner Amit Pro built a custom driver in the Flexum HMI to talk to the variable frequency drive on one port and to our UC300 on the other. So pump speeds, current draw, and running hours all flow back to SCADA. Finally, for the valve and pressure monitoring, 13 EM500 pipe pressure sensors at pressure-reducing valves track every twist of the gate and change of pounds per square inch, feeding machine learning alarms for predictive maintenance. With a handful of gateways, controllers, and battery-powered sensors, Amit Pro and Milesight turned a vulnerable, siloed water system into a resilient, data-driven operation. Here are 4 water level sensors based on 3 different technologies. Think of these submersible sensors as little divers you drop to the bottom of your tank or well. They measure the pressure of the water column above them to tell you exactly how deep the water is. Because they're fully sealed and built from corrosion-proof materials, they shrug off chemicals, extreme temps, and debris. Moreover, they're totally unfazed by surface foam, wind, or rain. Just to stick one in at the depth you need, and you get rock-solid, continuous readings without fuss. Imagine firing a tiny radar beam at the water surface and timing its echo. That's exactly what our EM410 radar sensor does. Its non-contact design means you can mount it above the liquid, even in sewers or tanks with corrosive gunk, and still get millimeter level accuracy. Foam, vapors, extreme heat or pressure? No problem. This IP68 rated radar just keeps on measuring, and with up to 7 years of battery life, it's a set and forget workhorse. Finally, these ultrasonic sensors send out sound pulses and listen for the return, giving you the distance to the water surface. They're a budget-friendly, non-contact option that's perfect for open channels, tanks, or treatment basins. As long as you're not dealing with frothing foam or crazy turbulence, you'll get reliable, precise readings. And with IP67 protection, and up to 10 years on battery, they will keep running through rain, sun, or snow. Choosing the most suitable sensor for water level monitoring depends on several factors. You need to consider the specific requirements of your application, such as the type of water body, the accuracy needed, the environment, the IP rating level, data transmission technology, and the budget. So here's a comparison table for your reference. Whenever you have a moment, please take a look. While the ultrasonic-based EM400 UDL and MUD and time-of-flight-based EM400 TLD sensors are great for many applications, there are some environments where they are not recommended. These include corrosive or harsh chemical liquids, high-salt environments, like areas exposed to seawater or concentrated saline solutions, fast-flowing rivers, sewer manholes, or measuring uneven solid materials, and also in the condensation-prone environments. In these cases, we recommend the EM410 RDL, the radar-based sensor, which is designed to perform reliably in more challenging conditions. In city facilities management, utilizing Milesight smart controllers and weather stations enables precise control of fountains and landscape irrigation in public green spaces. You might have one of these older models, like the Hunter ICC, Toro EC Extra, or Rainbird ESP series. These were very popular controllers in years past, and although they have since been discontinued, they remain widely used in commercial applications in cities and communities, still in operation today. So, can we make them smarter if your customers want to add soil sensors, weather stations, and other IoT gear without replacing their existing systems? The answer is yes. Look at the transformation. We can easily upgrade into an automation system by the Milesight smart controllers with digital input and output interfaces. Let me illustrate with an example. Devonport, Tasmania's gateway city in Australia, with a population of 26,000, is revitalizing its urban landscape through the Living City Master Plan. Under Deputy General Manager Jeffrey Griffiths' leadership, the city has launched a smart irrigation initiative integrating IoT and automation to optimize water use in public parks and ovals. Key requirements include seamless integration of diverse sensors, automated work order generation based on sensor data, reliable data collection for actionable insights, and compatibility with existing council systems to enhance operational workflows. To meet our customers' needs, our local partner, Indicium Dynamics, rolled out a Milesight solution. They buried 10 soil sensors 5 centimeters underground in sports fields, hidden inside pipes to avoid damaging the turf. These sensors track soil moisture temperature and conductivity in real time. They used 2 units, UC300 controllers, to send control signals to the Hunter irrigation systems through their digital input and output interfaces. These signals were generated by the Indicium Data Bus platform by taking use of the data from weather stations and soil moisture probes. Additionally, they installed 4 units of Milesight outdoor LoRaWAN gateways across the city to connect the sensors to Indicium's LoRaWAN network. The goal is to upgrade discontinued sprinkler controllers like Hunter ICC with digital input and output ports, keeping the original hardware but supercharging them with IoT smarts. And we made it. The upgrade works. Next, you can also take use of the IoT technology for smart fountain management in cities. For example, in the Slovakian town of Trenčín, managing the fountain manually was time-consuming and prone to mistakes. Ideally, the fountain should only run in suitable weather, specific temperatures, low wind speeds, and no heavy rain. Strong winds often caused water waste, and the managers couldn't adjust promptly. Enter Heliotics and their IoT-based solution. By using the Milesight UC300 IoT controller and Heliotics core, they automated the fountain's operation. The system includes a smart weather station that measures temperature, wind speed, and rainfall. This data is processed by the smart UC300 controller, which is connected to the fountain's main power system underground the fountain. The controller is perfect for remote monitoring and control. It has rich interfaces, cloud compatibility, and a built-in if and then command system. This allows managers to set up 16 custom commands to manage the fountain intelligently. The system continuously evaluates the weather in 3 levels. Green color means good, yellow means warning, and red color stands for critical situation. If conditions reach the red level, the system automatically turns off the fountain and restarts it only when the weather improves. This automated approach ensures the fountain operates only in good weather, preventing water waste and improving efficiency. Finally, the smart system helped the city council save 20,000 liters of water per day, offering both economic and environmental benefits. Let me take you through another great example of how Milesight is helping Turkey build a more resilient and data-driven smart city. Under Turkey's Digital City Initiative, the municipality addressed critical urban challenges, forest fires, floods, and weather volatility by deploying a LoRaWAN-based IoT ecosystem. First off, the municipality rolled out a robust LoRaWAN network through 20 units of UG67 outdoor gateways that blankets the entire urban area from downtown towers to remote base stations. This low-power, Long-range connectivity means our sensors stay online even in the toughest spots without racking up huge cellular bills. Then, hyperlocal weather intelligence with WTS 506. Our weather stations capture everything from wind speed and direction to barometric pressure and rainfall. That rich, hyperlocal feed powers smarter forecasts, lets planners model storm impacts, and pinpoints flood or fire risk zones with surgical precision. Next, for forest fire prevention, we mounted EM500 carbon dioxide sensors on radio towers all around the city. They feed real-time temperature and humidity data back to the control center, so you get an early heads up on any microclimate shifts that could spark a wildfire long before flames break out. Finally, for flood warning and prevention, at key waterways and drainage points, EM500 ultrasonic level sensors keep a constant eye on their depth. As soon as levels creep past safe thresholds, alerts stream in over Larawan, so crews can spring into action, closing valves or deploying pumps well before any streets or homes flood. All of these sensors talk to municipalities' existing dashboards in real time. The result? Predictive maintenance, instant emergency alerts, and data-driven decisions that keep the city and its people safer. Now, meet the irrigation-focused smart device, the UC51X solenoid valve controllers, which streamline watering by offering 2 DC latching outputs, up to 16 programmable schedule events, real-time water volume alarms, and optional external antenna support for LoRaWAN coverage in deep pits or fields, all wrapped in a rugged IP68 enclosure, and even able to trigger other Milesight end nodes through Milesight D2D if the standard LoRaWAN network goes dark. Moreover, did I mention that it's already fully tested with the 2 wired latching valves from the famous manufacturers like Hunter, Rainbird, and Burmad. Regarding the WTS506 weather station, I want to let you know that it's a professional, research-grade station powered by solar energy. It measures temperature, humidity, wind speed, wind direction, barometric pressure, and rainfall. Thank you for attending our webinar. For the latest updates and news, follow us on social media. We look forward to staying connected.